In this video, we're going to take a look at solving systems of equations by graphing. There are three main methods for solving systems of equations. This is the graphical method. We're going to graph the two lines, see where they cross. There's two algebraic methods that are often taught as well. They're called substitution and elimination. And what we're really trying to do is we're going to graph these two lines and find out the point they have in common. There will only be one point. For example, if I draw two straight lines, let's say that's a line, let's say that's another line. Well, there's only one place where they intersect. Two lines can't intersect in more than one place, unless they're actually the same line. It's only when you get a curve, like if I had, let's say, a curve like this, and I drew a line like that, well, the line and the curve could intersect in more than one place. These two actually intersect in three places, so that's possible too. So we're only talking about two lines. We're only looking for one point of intersection, though. So we're going to graph these two lines by using the y equals mx plus b method and also intercepts. So to put in y equals mx plus b method, I could rearrange. I want to get the y alone to solve for y. So I'm going to add y to both sides. And so that adds to 0. So I get on the left here just 2x minus 3 equals y, or y equals 2x minus 3. So that's my y equals mx plus b form. So the slope of this would be 2, or 2 over 1. Remember, if it's a whole number, the denominator is automatically 1. And the y-intercept is negative 3. So on my y-axis here, I'll put a dot at negative 3 right there. And the slope is 2 over 1, so up 2 over 1, up 2 to the right 1, and do it for a few points, and you'll be more accurate in your graph. There's 5 points, that's lots. And so this is what the line will look like. So that's why the y equals 2x minus 3 line. Now the second one here, the x plus y equals 3, if I'm going to rearrange and solve for y, I would subtract x from both sides like this, or you'll hear some teachers will say, well, bring the x over, it's a negative on the other side. So we would get y equals, and I'm going to write that negative x before the 3 just so it's in a more proper y equals mx plus b form. So y equals negative x plus 3. So that's my y equals mx plus b form for the second line. The slope would be, see, there's a negative 1 right here. So negative 1, and again, the denominator is 1 if you don't see it. And the y-intercept is 3. Whoops, b is 3. So we'll put a 3 here on the y-axis. And the slope of negative 1, or negative 1 over 1, means we go down 1. That's the rise is negative 1, and over 1. Down 1 and over 1. Down 1 and over 1. Let's do that for a few points, and you can graph that line. So that's the y equals negative x plus 3 line. So it looks like our intersection point is the 2, 1 point here. Now I'm going to erase all my writings here. And if you like instead to use intercepts to graph, so this is how you would graph these instead, using intercepts. So I'm going to write the 2x minus y minus 3 equals 0 standard form equation down. And define the intercepts. Remember, we substitute 0 in place of each of the variables one at a time. So let's put 0 in place of x, and I'm going to find the y-intercept for this one. So I'm going to put 0 here, so 2 times 0 at the beginning. Now that's just 0, so we'll just have negative y minus 3 equals 0 now. And we want to solve for y. So now, in order to solve for y here, I'm going to rearrange by bringing that y term to the left, or add y to both sides. So if I do that, I'll get negative 3 is equal to y. See, that y becomes a positive y over here. So negative 3 equals y, or y equals negative 3. That is the same thing. So that's my y-intercept. So y-intercept is negative 3, just the same as I had the negative 3 up here. And so now let's find what the x-intercept is. So we do that by putting 0 in place of y. So in our equation again, so the 0 is going to go here instead of there. So that's just 0, so we would just have a 2x here. And I'm going to rearrange and add 3 to both sides, so I have a 3 on the right here now, so 2x is equal to 3. And then if we divide out the 2, like that, we get x is 1.5. So 1.5 is going to be right here, halfway between 1 and 2. So there's the x-intercept, and again we could draw our line. So let's do the x plus y equals 3, 1 as well, if you prefer the intercepts. So if I put 0 here, I just get 0 plus y, or y equals 3. So y equals 3, so we have a dot right there on the y-axis. And so now let's find the x-intercept. So we'll put 0 in place of y instead. And so we get x equals 3. So x equals 3 right here. And again, we could draw our line. So the point of intersection is this 2, 1 point. X is 2, y is 1. And we could check that. This is how you check to make sure your solution is correct. And you should always check in the original equations, these two equations here. I mean, as long as you did the algebra right, it should work in these, but you know, what if you made a mistake going from here to here and everything else is correct? So that's why it's a good idea to check in your original equations. So in my original equation, the left side is this 2x minus y minus 3 equals 0 expression. So if I put my solution, x is 2, y is 1, in place of x and y here, it should equal, that should evaluate out to give me what's on the right side of the equation, the 0. So I'm going to put my 2 here and the 1 here. So this would be 4, minus 1 would be 3, minus 3 is 0. So that works out to be 0, which is what's on the right side of that equation. So that point is definitely on that line. So let's check and see if it's on this line here now. So the left side is the x plus y part, and if I put 2 here and 1 here, so we're just adding 2 and 1, that works out to 3, and you see 3 is what's on the right side. So that said to satisfy the equation because it makes that both sides have the same value, and so that guarantees that that point is also on the second line, and that's what we're looking for. The point is on both of the lines. So that's how you typically solve a system of equations, by graphing. Again, you don't have to use both methods for graphing it here. I'm just showing you both of them because those are two fairly normal ways to graph lines. Okay, second and last example. So this is more of an application. We're given this scenario. Evelyn's throwing a wedding anniversary of the 50th for her parents, and she has 2 caterers to choose from. Top Line Caterers charges no flat fee whatsoever, but they do charge $30 per person. And then the one she's comparing it to is this Grand Caterers, and they charge a fixed fee of $200. That's their fixed fee, and then on top of that, $25 per person. So we're asked to determine when each caterer is a better deal. And that we're assuming that they're the same quality. Of course, if one's better than the other, or much better, then a little bit extra cost might mean you would go with a better one anyway. But we have to assume they're the same quality to adequately compare them. So we need to make equations for the 2 of these. So the Top Line Caterers, and I'm gonna write a let statement here first. So I'm gonna let capital C represent the cost in dollars, and P the number of people at this anniversary party. So for the Top Line Caterers, and this is my symbol I'm using for top line, C of and then TL stands for top line, and they just charge $30 per person. There's no flat fee. So if you remember back to grade 9, this is a direct variation because there's no flat fee. So it's just 30 times the number of people. C is 30 times the number of people. And so let's graph, actually I'll write out the second equation too. Grand Caterers, they charge a fixed fee of $200, so there's the fixed amount. This is a partial variation if you remember back to grade 9. And on top of that, they charge $25 per person. So it's $200 plus 25 times the number of people. So now these are both in y equals mx plus b form, and you can use a little bit of that to graph them, but the problem with the numbers are quite large. It doesn't go by scale of 1, 2, 3, 4. We wouldn't worry about a wedding anniversary party for 4 people. We're probably talking about dozens of people, maybe 100 people, maybe even more. Okay, but my graph here is going to go up to 100 people. So for the 30p one, there's no fixed amount on the end. So the y-intercept, or in this case the cost intercept, would be 0. So the graph would start right here. Now, the slope is actually 30, but I can't really go over 1 and up 30, over 1 and up 30, because the scale isn't helpful because it's so big. But what you can do, I'm going to bring my calculator over here, is we could find a couple other points. So instead of going over 1 person, we could go over 20 people. So if I put 20 in place of p here, if I just do 30 times 20, then that's 600. So for 20 people, it'll cost 600. And so that kind of gives me a slope I can work with. If I go over 20 people, I'm going up 600. If I go over another 20 people, because this is a direct variation, it's just going to go up another 600. So that point would be on the graph. And then I have a few points. I mean, I can graph another one too. Let's bring the calculator back one more time. So let's say we put at the end of the graph here 100 people in. So 30 times 100, that's 3,000. So this would be right up here at the top at 3,000 right here. Well, not quite the top, right there. And we can draw a line between them. There's 4 points. That's lots to graph a line. And so that's the top line caterer one. Now the second one here, the grand caterer, the fixed amount is 200. So we will start with putting a point right here. And again, the slope would be 25, but I can't really go over 1 and up 25 because the scale doesn't work good for that. So what we could do instead is go and put 20 or 40 or 60 or something. I'm going to do 40. So I'm going to go 25 times 40 plus the 200. And that's 1,200. You see, this is actually 1,000 plus the 200 is 1,200. So for 40 people, it costs 1,200, so we'll put a dot right there, and we can draw our line through them. And so that's the grand caterer one. And actually, that point is where the two of them are the same. For 40 people, they both cost $1,200. So at 40 guests, the caterers both cost $1,200. We're asked when each is a better deal. So the blue one, which is the top line caterer, they're cheaper below 40 people because they have a fixed cost of 0. So that's why below 40 they're cheaper. Now remember they're the same here, and so after 40 people, the red one, the grand caterer, is cheaper, and that's because after they have the same cost, see, every additional person here is only $25, whereas every additional person here is $30. So, like, after 40, this one's actually $5 per person cheaper, so that's why the grand caterer is cheaper after 40 people. So there's an application of using solving a system of equations with graphing, and that's the end of the video.